find all the zeros of f of x equals to x cubed plus 7x squared plus 11x minus 3. Again, if I was to try to find all the zeros, the first thing I would do would be try to factor. But if you try to factor this 4-term polynomial by grouping, you could see that it will not factor. So I need to start by finding my possible rational zeros by finding my p's and dividing them by my q's. Well, p is 3 and q is 1. So your factors of 3 would be plus or minus 1 plus or minus 3. Your factors of q plus or minus 1. Well, if you divide every p by every q, 1 divided by 1 is 1 and 3 divided by 1 is 3. So I end up having 1, 2, 3, 4 possible rational zeros. All right, so what I want to do is find all the zeros. So let's begin testing. To test to see if a number is a zero, we put the number in the box. So let's start with 1. I check for descending order. I check and make sure that I'm not missing any terms. And I'm okay. Everything's in descending order. I have x cubed, x squared, x to the first, and a constant. So let's pull down those leading, those coefficients and my constant. So I have 1, I have 7, I have 11, and I have negative 3. Now I'm looking for to get a remainder of 0. So pulling down 1. 1 times 1 is 1. Add, I get 8. 1 times 8 is 8. Add, I get 19. 1 times 19 is 19. When I add, I get 16. So 1 is not a 0. So keep trying my possible rational zeros. I have negative 1. So let's try negative 1 to see if it's a 0. Using the same numbers from the original problem, let's test to see if negative 1 is a 0. So pulling down 1. Negative 1 times 1 is negative 1. Add, you get 6. Negative 1 times 6 is negative 6. Add, you get 5. Negative 1 times 5 is negative 5. Add, you get negative 8. So negative 1 is not a 0 because we did not get a remainder of 0. Remember, these numbers are your remainders. In order for you to get a 0, you have to have a 0 remainder. Next, let's try positive 3. I only have 4 possible rational zeros. So we need to exhaust these, and let's try 3. So I have 1, 7, 11, and negative 3. Let's see if 3 is a 0. Running it through synthetic division, pull down 1. 3 times 1 is 3. Add, you get 10. 3 times 10 is 30. Add, you get 41. 3 times 41, 123. Add, you get 120. We do not have a remainder of 0, so 3 is not a 0. 3 is not a 0. So, let's continue on with negative 3. So now I have negative 3. 1, 7, 11, and negative 3. Again, using synthetic division. So, pull down the 1. Excuse me. Negative 3 times 1 is negative 3. Add, you get 4. Negative 3 times 4 is negative 12. Add, you get negative 1. Negative 3 times negative 1 is positive 3. Add, what do we get? 0. Finally, negative 3 is a 0. So, of all of the possible rational zeros that I had, these 4 were my possible rational zeros. Possible rational zeros. Of the 4 numbers that were possible rational zeros, only one of them was a real 0. Now, remember, if your highest exponent is 3, you will have 3 zeros. Some will be rational, some may be irrational. So, What we need to do next is, being that we did find 1 to be a 0. Remember, this is x cubed in the original problem, so lower this down 1, x squared plus 4x minus 1. So let's take that x squared plus 4x minus 1 and set it equal to 0. Now normally we factor. But if I tried to factor this, factors of 1 are 1 and 1. There's no way that when you subtract 1 and 1 that you're going to get 4. So I cannot factor this. But this is a quadratic equation. In any quadratic equation, we can find solutions by using the quadratic formula. So let's remember the quadratic formula we talked about on your first test. X equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right? Now, this is in the form of ax squared plus bx plus c. So my a is 1, my b is 4, and my c is negative 1. So to find the remaining 2 zeros, we've got to run it through the quadratic formula. So I have x is equal to negative b, that'd be negative 4, plus or minus the square root of b squared. I'm going to put parentheses around, that's 4 squared minus 4 times a times c. A is 1, c is negative 1. All divided by 2 times a is 1. So I have negative 4 plus or minus the square root of 4 squared is 16. Now multiply all of this together right here. This negative 4ac, multiply it all together. Negative 4 times 1 is negative 4, times negative 1 is positive 4. Divided by 2 times 1 is 2. So we end up with negative 4 plus or minus the square root of 20 divided by 2. Now, to finish this problem, I need to reduce this radical. Can I take the square root of 20? No. But what's the largest perfect square? Think of your perfect squares. 4, 9, 16. Those are numbers that you can take the square root of. What is the largest perfect square that will divide into 20? Well, I can break that 20 down to 4 times 5. So I have negative 4 plus or minus, I divided 4 into 4 times 5 divided by 2. Now the square root of 4 comes out as 2. 5 staying under, divided by 2. So here I took the square root of 4, came out as 2, right here, and this 5 stayed under. Now I can divide each one of these numbers. I can divide 4 by 2 and 2. I can divide 4 by 2 and 2 by 2. Let me go over that again. I had square root of 20. I can't take the square root of 20, but what's the largest perfect square that will divide into 20? Your perfect squares are like 4, 9, and 16. Well, 4 divides into 20. 4 divides into 25 times, so that's where I got 4 times 5. Well, the square root of 4 came out as 2, and 5 stays under. Now to continue simplifying here, divide each one of these by 2. Divide negative 4 by 2, and then divide 2 square root of 5 by 2. When you do that, you end up with negative 2 plus or minus the square root of 5. So there's your other 2 zeros. They're irrational zeros. So my final answer would be 3, let's go back, negative 3 gave me a remainder of 0, so that's an answer. When I ran it through the quadratic formula and reduced, I got negative 2 plus square root of 5, and then I got the other answer, negative 2 minus square root of 5. So there's your 3 zeros. 1 was rational, and 2 were irrational. Those 2 irrational ones were found when we could not factor, and we had to run it through the quadratic formula, and then I simplified, reducing on down to negative 2 plus square root of 5 and negative 2 minus square root of 5.